to you about one of my favorite topics, which is how to build AI products, or in other words, how to think about dealing with machine learning problems and AI problems with a product lens. In what is going to go on for the next hour, hopefully I can convince you that that's the right way to think about AI problems in general, and hopefully give you some frameworks that you can follow. I have planted some hands-on activities, but I guess since I don't see the audience, it might be more difficult to do those. So hopefully you can take a note of those and go offline and try them out on your own. So let's go through this quickly. Essentially, one of the things that I would like to argue upfront is the fact that a lot of us think that data science work and machine learning work is 80% data wrangling, and 20% modeling. That's a very often quoted thing that people talk about. However, I think that's really not how reality happens. In reality, you really should have spent about 40 to 50% of your time on handling data and wrangling that, and about 30 to 40% on modeling and deployment of those models. Because if you prepare your data as well as you can and deploy it and build models on it, but those models don't go into production, then that would be extremely challenging because nobody can use them. And of course, you have to spend anywhere between 10 to 30% of your time on making sure that you're working on the right problem, you're setting it up for people to see it, and hopefully use it. And the combination of all of these factors means that you really need to think about AI in a much bigger, through a much bigger lens than what we usually do. So I'm going to go through some principles that will help us through this process, and hopefully will provide more context about what we're talking about. So the very first thing that I would like to go through is what is the difference between an AI product and an AI project. So the very first difference, in my opinion, is the type of time scale that you're dealing with. When you're talking about AI products, you're dealing with problems. You're dealing with problems that are on much longer time scale. It is an ongoing effort, rather than AI projects, where there is a very clear start and a very clear end. Another important thing is when you're dealing with products, it's not only about the model and the data that comes to it and the data that leaves it, but rather about everything around it, like what the users want, how can they use it, can they actually use it, what kind of benefit are they getting from it, etc. And another interesting aspect that is usually not talked about enough is how building a product means that there are multiple components of the work that you're doing that are owned by you, rather than just you're doing some work and then we'll hand it off to someone else. And that has a lot of interesting implications in terms of the dynamics that the team will have and how it will be placed in the organization. Finally, success for a product is measured by realized value. In a lot of AI project type of activities, the success is measured by some sort of a projected value, like I estimate $3 million of saving in this case, rather than in the case of product, you really have to work hard for that $3 million to realize. And until that realizes, your work is not done, which means, again, has very, very significant implications for how the machine learning data science team might behave. I wanted to emphasize the fact that I'm sort of putting AI in parentheses here and with a question mark. And the reason for that is that, if you're thinking like this, like what I'm saying on the left, you are really building a product, and AI might or might not be involved, and AI could be a component that you will use in your stack, and it's not necessarily the case that you are building an AI product. And I would even, go extreme and say there's no such thing as AI product. You usually build products, software products, for example, and AI could be part of your stack. So let's go through some principles quickly. The first thing is, when you're trying to really deliver value through AI to your organization, to your users, customers, really understanding what they go through and what problems they have and how their business works, how their lives work, is extremely important. So either yourself or somebody in the team needs to have domain knowledge. I can't count how many times I've seen machine learning data science teams who go on about building models without talking to any potential users. And that's one of the biggest sins that I've seen. It's extremely dangerous because most of the time you end up building things that users don't really care about. And that's a lot of wasted time. The third important factor and principle to follow is you really need to be obsessed with a problem to solve rather than a solution. Again, I can't count the number of times that I've seen people coming to me and saying, oh, I want to do an NLP project, like, what can we do? And, it really blows my mind because even business people talk like that. And I'm like, you are running a business. What are the problems in your business? What are you trying to optimize? So you really have to focus on the problem and then find the right solution for that problem, which is often the way we do it reverse. Like we fall in love with a new technique, a new technology, and we're trying to find problems for that. And of course, the stories matter. Like when you're talking about an ML project, a lot of the time you're solving a real problem that somebody has. It is either a business or a customer, or consumer, etc. And really understanding their story is really, really important. And a lot of the time, the problems that a lot of machine learning data science teams have is that they don't understand the problem well enough to tell a good enough narrative about it. And they always complain about, executives not buying into their visions, et cetera, but, at least part of the problem is on ourselves because we don't understand the problem well enough to tell a good story about it. Yeah, and again, like just to emphasize this, don't try to find a problem for the solution that you love. And again, I've seen this happen quite a bit. I've done it myself as well. Next point is that iteration is extremely important. No ML projects, no ML products are really going to be perfect on day one. And you really have to go a lot of iterations to learn more and more about the problem, to learn it more deeply, and eventually, converge to something that is meaningful and impactful for the users and for the business. We deal with this at my company, Aggregate Intellect, all the time. Like we're constantly iterating over various ideas to see, what is the actual deep problem that the users have. And, obviously, if you don't have a success metric, you are kind of doing random walk in the dark because you're just moving towards something that nobody knows what it is. So you really have to think carefully about what problem you're trying to solve and how you can quantitatively measure how close to that you are. And of course, very important issue is the ethical gray zones. Like a lot of the time, you're too focused on the technology, and we forget to think about things like, is this data kosher to use? Can I use it in this way? Or, am I informed about all the biases that my data and my models have? And how can I make sure that those are not going to impact intersections in adverse ways? And probably a lot of examples in that case. And this is one of the most important advices that I got early in my career. That is, if you're building a product and if you're stuck, you have no idea what to do, just talk to the users. They usually provide points of view that you are not thinking about, and that usually can help you move forward. And lastly, a lot of the more technical folks like myself think that dealing with the whole product thing is not their problem. They're just there to build cool models, and they don't care about the rest. But unfortunately, the reality is that this whole thing, like the whole data science, machine learning, sits in a business context. And if your work doesn't contribute to the business, then your work is going to be meaningless. And unless you strive for actual impact, your work is not going to matter at all. So on personal satisfaction level, all the way to being able to have good career progressions, I think it is extremely important, and it is a sign of maturity to be able to think about problems beyond just the models. All right, so let's go into some frameworks. So one of the, I guess, early things that we should get out of the way is how you should think about the problems when you're trying to identify ML opportunities in your organizations. So normally the way data science teams work is that they just hear a bit about a problem, and they grab a piece of data and immediately start the program. And that's a very common way of working, and I think that's very, very misguided. In very, very rare cases, what happens is that they start from a very, very specific idea, and then they start program it, and then they go on, and then they wonder why it is not working. In reality, what really needs to happen is that at the very, very beginning, before you touch any code or data, you really have to examine a range of ideas that exist in relation to the problem that you're trying to solve. If you remember, one of our principles was to fall in love with a problem and be obsessed with it. And if you are in love with a problem and obsessed with it, the next step is to generate a range of ideas that you can explore about that problem. We're going to get into a framework about that shortly. But the first idea is to generate as many ideas as you can. The next step is, out of these ideas, you select a smaller number and move on and do mockups. And mockups are simple, demonstrations of how, like if you solve this problem, how can the user interact with your solution? In both of these stages, it's extremely important to talk to users, show it to them. Users can be actual consumers, or the business stakeholders in corporates, etc. But essentially, the purpose of these two stages, or all the stages that we're going to talk about, is to understand which of these ideas are bad ideas that are not going to work. At first, you invalidate them on the idea level. Then you show them some artifacts, like a simple mock-up of what the UI, for example, would look like, and see how they react to it. And again, you drop a bunch of these because they're bad ideas, and then you build prototypes. So prototypes are very similar to mock-ups, except that they are more real-looking, and they have a bit of the functionality that you would have. Please note that up to this point, there's no touching code or data yet. You're just trying to understand the problem better. And every time you're trying to make it slightly more realistic to make sure that we understand the problem deeply and the solution that we are providing. And only then you start programming. And if you're programming, you're going to, if you're doing ML modeling at this point, you probably are doing a bunch of experiments. You're going to try out a bunch of different models, a bunch of different pipelines, various types of feature engineering, etc. And some of this might work, and those that work will eventually turn into a product that you're building, and that product obviously has the code aspect, has the data aspect, has other things like delivery to user, like through a user interface, etc. That you have to think about at this stage. And again, like you would be doing experimentations with many versions of this, but hopefully much more focused at this point because of all the work that you've done. And eventually, hopefully this product can drive business. Again, you might have to experiment a bit with your business models and how you're dealing with it. And eventually, hopefully this will drive some sort of profit. In terms of time scales, the amount of time you have to spend on each of these, it's really inversely proportional to the number of items that you're dealing with. So initially, you have to spend on the order of hours to generate many, many ideas. If you're spending more than a few hours on generating ideas, you're probably getting too deeply into one of your ideas, which is usually a very bad idea. Then doing research using your mockups should be on the order of days. Research on the prototype should be weeks. Programming shouldn't take a few months. And turning the program into a product shouldn't take more than about a quarter. And business usually happens on the order of year, and profit more than that. And it is very, very likely that you have to go back and forth between these stages. Like if you're doing your programming and none of the ways that you're doing your coding is really helping you get to the success metric, you really have to go back even all the way to the idea stage and think, did I take everything into account, or do I need to change anything? And so you might need to do a lot of iteration back and forth between these stages. And another way to think about what's happening here is that you're going through 3 different stages of discovering a problem, doing a short-term validation of that problem, and finally a long-term validation. And if you notice, I'm even putting the product, business, and profit under long-term validation, because everything is going to change. Like the user's behavior and taste is going to change. The requirements of your corporate business is going to change. So you really have to be constantly measuring things and constantly figuring out if your solution is still good. And if it is good, what else can you do? Like, can you collect data through your product to improve things even further? And of course, you have to go through this process for every feature of the product that you're building. You definitely start with the core feature. We will talk about that a little later. But you really have to repeat this for every single feature. Otherwise, you will be building features that are not useful for the users. OK, so let's briefly talk about what I call invalidation framework. And I'm putting invalidation in invalidation because this is not really a validation framework. Like, what you're trying to do here is to invalidate bad ideas, because that's the risky thing to do, to spend time on an idea that is bad. So what happens in invalidation framework is that you go through those stages of discovery, short-term validation, and long-term validation. And the steps are in more detail the following. You figure out what you should do. So you go through some process to determine what is the right problem to work on, what is the right problem to spend time on. Then you come up with a list of assumptions that you're making about that problem, and come up with a validation plan. So you have a bunch of assumptions, and most of the things that you take for granted and you think that you know are assumptions, and you really have to think about them. So you need a validation plan, something like, I'm going to talk to 10 users. If, I don't know, 7 of them say X and Y and Z, then this assumption is validated. Then obviously you have to do your research, which is talking to users, Google research, market research, whatever needs to be done. And you learn from your research, and you most probably need to repeat this process, because based on your learning, there are a bunch of new things that you have to investigate. And for your validation and research, you need artifacts, and you have to design experiments. For artifacts, we gave examples like mockups and prototypes before, but definitely an engineered solution is also an artifact that you would use to do measurements. And of course, you have to design experiments that are that can give you information that you need about the problem you're trying to solve on the users. And the learning happens through data. So you collect data. At first, it is qualitative, sort of like interview notes. Then it becomes quantitative in your short-term validation because you have a base pipeline that is able to collect data, and you can use that data to make decisions about the future of your product. And of course, when you are in long-term validation stage and you have an engineered solution, then you're collecting user data at large scale, and you definitely can use that to build the future of your product more effectively, or even come up with new features you should build. And this is a framework that we use very often. Whenever we're dealing with a new problem, we always go through this framework to make sure that we're building the right thing, something that the users actually want. Okay, the next framework is what I call so what framework. I later learned that this framework actually has a name. It is called Abstraction Ladder. But the basic idea is fairly simple. And this framework can be used in many cases, like we at least use it in almost every single discussions that we have internally. So the idea is that you can use this framework to articulate what you want to do more clearly, and articulate why you want to do that. You can very easily, using this framework, identify the assumptions that you're making behind a problem or a solution that you're proposing. And also, you can use this framework to prioritize work. Like if there are several pieces of work that you have to do, and you don't know which one is the best, you have to sit down with your team and do this exercise for all of those problems to understand why you want to do them and which one is the most impactful, the important one to do. So how it works is that you sort of write down exactly what you want to do, and you ask yourself, so what? And you write down the answer, and you read that answer, and then ask yourself, so what again? So essentially, you ask yourself, why do I want to do this? And then ask yourself, why is that thing that I wrote down an important answer? And you just keep repeating that. And repeat that a few times until you get to a very fundamental reason that you want to solve the particular problem. To give you an example, I can write down that I want to build a common pest detector for farmers. So this is some random idea that I might come across and think that, oh, that's a good idea. I can probably do something like this. So what I do is that I use this framework to go through this and understand why I want to do this. So the first step is I ask myself, why do I want to build this? So that the farmers can identify their crop is infected as quickly as possible. And then so that they can tackle the issue as soon as it appears and focus on the parts of the crop. So why do I want to help them to focus on the parts of the crop? I ask myself, so what again? And I keep repeating this until I'm at a point where I have a very good understanding of why I want to solve this problem. And of course, this is very important because when I get to this point, I have sort of a mission statement. A lot of the time, people struggle with figuring out what mission, what vision they have. But going through this exercise really helps you get to that mission. And an important factor here is that you can really use this framework for any problem size that you're dealing with. And you can repeat the same thing with why now to discuss the urgency of the problem that you're working on. And it is very, very similar. So you do exactly the same thing. And this is a very, like most of these frameworks are very helpful to drive conversations within the team. So a lot of the time, you don't have a very good, like the parts of the conversation are not on the same page about the problem. So going through this exercise can really help them get on the same page by discussing each of these points. And at some of the steps, you might even run into the situations where you can't really go beyond, like you can't really answer, why do I want to do this? And those are cases that you might have to step back, go talk to your users, do some Google research, do some market research to really be able to understand why do farmers want X. Anyway, I'm not going to go through the why now framework, but it's very similar, same structure, and you use it to understand the urgency of the problem you're trying to solve. And a few points to remember is that most of the things that you're writing down are assumptions. You still have to validate them. And ideally, you should find numbers to back up the things that you're writing down. Like if you're saying, farmers really, I want to build this pest detector because farmers really suffer from, this kind of pest. You really have to find a stats on it. Like, do they actually suffer from this kind of pest? Farmers in what locations and how much are they impacted by that, et cetera, et cetera. How would you transition between different steps is also an important thing to think about. Like if you're saying, the farmers really need this because this is going to help them save cost, you have to think about how are they going to save cost if you give them a common pest detector, for example. And a very important and common mistake that I see when people use this framework is that they do it from their own point of view or from their business's point of view, while this should be done from the user's point of view, because you're trying to understand what is the value that the user is after. Okay, so here is an activity that I wanted to do, but again, since it's kind of harder to do that with a crowd that I don't see, so take a note of this, try to repeat this exercise at home, see if you can work it out. Okay, so before I go forward, I would like to show a few examples of some of the books that I've read that really helped me form my opinions and way of thinking about this problem. Inspired is one of these books. The Innovator's Dilemma is another fantastic book, and many of you are probably familiar with Lean Startup. Okay, so let's move on to the ideation. So as we discussed before, the very first thing that you have to do is to generate as many ideas as you can. And I told you that the so what exercise that we did is called Abstraction Ladder. So I'm showing the same example here. So I want to build a common pest detector for farmers. So this is this is sort of the initial idea that I had. So now I can move on this ladder up and down by asking myself why, the way we did in the so what exercise, and that will make my problem statement more abstract. Or I can ask myself how, which will make the problem statement more concrete. For example, if I ask myself how once, I would say we would do this by building an image classifier. So this is a more concrete idea. Or I can ask myself why and get to so that they can identify if their crop is infected. That's a more abstract problem statement. And ideally, you want to have like when you get to the very abstract problem, as I mentioned, that's sort of your mission. That's the vision that you have for what you're building. So you ideally want to have only one of these. But the very concrete idea, ideally you want to have many of it, because maybe the image classifier is not the right solution. Maybe you have to have a different concrete idea that you will build. So how do you do this? Essentially, you turn this ladder into a tree. So the way you do it is that you grab one of your very abstract ideas, you ask yourself how or how else. When you ask yourself how, it just moves you up on the ladder once you already have this idea. But you also ask yourself how else. So if this was, I want to help them save cost, you had this idea already. So you ask yourself, how else can I help them save cost? So that would be your other abstract idea. And you just keep repeating this as many times as you wish, and you end up with a bunch of concrete ideas. Again, to put this in real form, here is again for our farmer friends. The very abstract idea is that we want to help them with targeted applications of pesticides. And then I go through this exercise of asking how and how else and get to a bunch of concrete ideas where image classifier is one of the ideas, but I can, do a bunch of other things. I can monitor the soil. I can monitor the weather data. I can look at the infection, historical infection patterns in the area, blah, blah, blah. So you get the idea. You essentially start from some abstract idea and you get to a bunch of concrete ideas. This is best. And by the way, that was the original idea that I had. And this is best done as part of a group. So you ideally want to bring in your team, including data scientists, machine learning engineers, not necessarily all of them, but at least one or two of the more senior ones, probably your designers, and a bunch of people who are very familiar with farmers, and ideally, a couple of farmers as well. Okay, so the next stage is discovery. So we are going to essentially go into more details about each of the stages of discovery, short-term validation, and long-term validation now. So in discovery, you're trying to figure out three things really on a very high level. So you want to know the epic meaning for what problem you're trying to solve. So what's the grand vision of this problem? You want to know a business strategy, like how is this going to make money and how much is it going to cost me? And you want to have a product strategy. How am I going to build this? What am I going to build first, etc., etc. And this is sort of a linear relationship between them. Like you really need to have your grand vision first before you can determine what kind of business you want for that vision. And that will put limitations on what kind of product you can build. So another way that people talk about this is, you have to de-risk in three areas of desirability, viability, and feasibility. So desirability means, are there people who care about this problem that I want to solve? Who are they? Where are they? Why do they have this problem? Viability is, do they want this solved enough to pay for it? Are they going to pay enough to cover my cost and even, make enough money to grow? And feasibility is, okay, can I build something like this? And obviously, these all will affect each other. Like you might come up with something that is desirable, but technically it's very challenging to build. So you have to go back and find another thing that is desirable, etc. So as I said, in desirability, you're looking for who needs it, what problem do they have, and do they care about it enough that they're doing something about it now? In terms of viability, you want to know, how many people are there that have this problem? How big and major is that problem? Is it a nice to solve thing, or is it really important for them to be solved? How much would they pay for it? How much are they paying for it right now? Can you reach them? Like you might find a bunch of people that really need this problem solved, but you have no way of reaching to them, so they're useless to you. Who else is solving this problem for them? So essentially, who's your competition? In terms of feasibility, obviously, the first question to think about is, can you buy a solution for it? Because if you can buy it, and if you have the money for it, it's a waste of time to build it. And a lot of us like to build things, so we usually ignore this question, but it's extremely important to think about. Can you partner with someone else? Like if somebody else is also partly solving this problem and you kind of identified them in this stage, can you partner with those and solve part of your problem and hopefully help them solve the problem faster? And should you build it at all? Like is this the right strategic move for your organization and team? And assuming that you do decide that you want to build it, what are the minimal set of features that you need? Because a lot of us do build way too many features for our products and kind of drown in the features, and we never really deliver any sort of meaningful impact. So identifying the one so-called killer feature for what you're building is extremely important. And once you know that, there are a bunch of other things that you have to think about. You have to think about what kind of architecture is needed to build something like this. What kind of infrastructure can that architecture sit on? And based on those, you can determine the tech stack that you have, the kind of team that you have to build, like what kind of skills your team needs, what kind of data you need, and how can you deliver the results to the user. And you're probably familiar with these. In the desirability stage, you really have to talk to people. For viability, you have to really do market research, and for technology, for feasibility, you have to do technology research. And a big problem that I've seen in many data science teams is that they don't go through this rigorous process before even putting together a data science team. And the data science team end up doing a bunch of science fair kind of projects, which go nowhere. And then they're pulling their hair out thinking, oh, what went wrong? We did everything right. Although they literally started by taking a bunch of data and trying to build models on it without doing any of this prior work. Okay. Again, I wanted to do an activity here, but I hopefully go through it very quickly. A very, very important artifact that you have to create based on all the research that you did previously is the product strategy. And this is one of the best ways that I've seen this done. So say you're trying to solve a data science problem. What you really have to think about is a success metric that is quantitative, as we discussed before. Say in this case, it is reduce the annual cost of pesticide. So then you have to, based on all the research that you've done that we talked about so far, you really have to understand what are the contributing factors into this cost. So it is the frequency of the use of pesticides, the amount that is used, is cost per kilograms, and cost per day applied, blah, blah. So you have all the factors. Based on all these factors, and again, based on your research and the fact that I said you need to find the stats on these, you have some numbers for those. And based on these numbers, you have some baseline that you can beat. So you decide the product features that you need to build to address each of these. For example, for the first one, which is the frequency of the use as a contributing factor, you can build a product feature that is something like continuous monitoring to apply pesticides only when needed, and a bunch of other product features based on exactly what the contributing factor is. And hopefully, based on your so what exercise and why now exercise and all the user research that you've done, you would also be able to identify one of these as the first thing that you have to build. You might decide to build the rest, but that could be something for later. And obviously, you will come up with some sort of a timeline for that feature that you're building and timelines for all the other features. Okay, I know that I'm storming through this, but again, if you have any questions about these, please put it in the chat. I'll try to answer them. And if I don't get to them, please do email me. My email address is at the bottom, and I'm happy to talk about them. Oh, there's a question. Yeah, I mean, so the question is, what are the common mistakes in identifying revenue-generating ML opportunities? I mean, the common mistake, the most fundamental mistake, is that people try to jump over all the steps that I mentioned and just go directly to data and modeling. So when, and that's something that usually is a big problem, because a lot of the machine learning folks think, oh, that's a problem for the product, for the business to figure out. But the reality is that everyone has to be involved in making all these decisions. For example, the machine learning folks, they really need to understand what problem they're solving, because otherwise they're just modeling in the vacuum in dark, and that's not going to be helpful. So jumping, not doing proper invalidation, I think, is the most common problem that I see, because people end up working on problems that nobody care about. In my previous teams, I did observe a lot of cases where, the team spends, I don't know, even 6 months, a year on some problem. They build models, and then the model ends up either on a shelf, or even if it is deployed, the users can't use it because that's not exactly the problem they had, and nobody identified it early enough to do something different. Anyway, let's go forward. So next stage, after hopefully so far you have identified what problem you should work on, and you de-risked it as much as possible. So you're going to move on to a short-term validation. For this, you have to do different types of prototypes, as I said. this is a very nice chart showing what kind of prototypes you can use, what kind of technical complexity they have, and what are the design requirements for them. So the low fidelity mockups that we talked about are the first things that you will use because they are very simple to design and very simple to make. And that's the thing you use to test your value proposition. Essentially, what is the thing that the problem that you think the user has the right one. There is high fidelity prototypes that we talked about. The reason that you use those is to test, can the user really understand what you're building for them? Because if they don't understand it, they can't use it, so it is useless. And feasibility prototype is extremely important. So this is the part that the data scientists spend most of their time. Like they just pull up a Jupyter notebook, they start playing with data and modeling, and they don't realize that they're just prototyping. This is just a very small step in the whole process. And what they're doing there is really validating or invalidating the technical ways that are not going to work. So a lot of data scientists spend most of their times here, and they think that this is the value they're creating, although what's happening there is that they're just simply prototyping to determine the technical limitations, and they still have to do quite a bit of work before this thing even gets to a more complex prototype, let alone a product. And finally, you have to work with a live data prototype, which is an end-to-end pipeline with the data and everything that is live and goes through it and is deployed. The thing about this one is that the reason that we call this a prototype still is that this is built with a very, very basic model and a very base pipeline. So this is not your final delivery, but essentially something that you build very quickly to make sure that you have all the steps of the process in place. And this is a very good way to identify very quickly a lot of the problems. Like in a smaller companies, you might not have some data that you need. You might not have some infrastructure that you need. And these are things that you have to identify right away. In bigger organizations, this is a good way to understand, to let other teams that will support you know that you need this kind of data engineering, you need this kind of infrastructure, or design components as well. And one type of prototype that this chart doesn't cover is viability prototype. And this is essentially something that you create to try to sell your idea to business or your users and say how much they would pay for it without actually building the product. There are many, many interesting ideas in this one, but I'm not going to go through because we don't have much time. And okay, so for the short-term validation, essentially you want to build a base pipeline. That's your goal. And the way you start this is by data collection. Then you do exploratory data analysis. Then you do your modeling. A lot of data science machine learning teams sort of stop between this EDA and modeling, and then they go anywhere else. But as you will see, there's a lot that will go on still. So you still need to build this model. You need to package it. You need to deploy it. You need to deliver it, and you need to collect feedback. And this is an extremely important step because a model that is sitting in your Jupyter notebook is not going to help anyone. The model that is deployed is going to help someone probably, but until you get their feedback, you wouldn't know if it is actually helping anyone. So this feedback collection is extremely important. And the very important question to ask yourself after you have the feedback, and the feedback can be literal, qualitative feedback, or it can be quantitative feedback based on whatever you're collecting, like explicit feedback, like where did the user click, et cetera, or actually sitting down with them and interviewing them. So if it didn't solve their problem, you obviously have to go back to various steps of your pipeline and change things. You might need more or better data. You might need to improve your model, or you might need to improve your engineering pieces. And obviously, there is a one-on-one mapping between this pipeline and the architecture you design. which is also an extremely important step that people delay very, very much. This is another very common mistake that I see. People spend a lot of time on thinking about the data and exploration and the model, and even they get into deployment, but they never really think about architecture until very, very late, at which point they might have made decisions that are not compatible with the available architectures that they have and infrastructures that they have. So thinking about architecture upfront is extremely important as well, because that will really guide what kind of pipeline you can build. And this is an example of the architecture. Again, the plan was to do some exercise here, but you would build some architecture that talks about how are you going to keep your data and access it. How are you going to what tech stack are you going to use for your development and environments? What are you going to use for your packaging? How are you going to manage your artifacts? How are you going to serve your models and results? And how is the user going to interact with your model? Okay, moving on to product team. Once you have your, again, like one of the common problems I see is that people hire a bunch of data scientists and ask them to do magic. That's never going to work. You really have to form your team after you have your product strategy, because it's only then that you can determine what architecture you need to solve your problem, which will determine your tech stack, therefore skill sets you need, therefore what kind of product team you need. But most commonly, teams, machine learning teams, in my opinion, need to have product managers, product designers, data engineers, data scientists, machine learning engineers, and potentially UI developers. And I think all of these have to be on the same thing. If it is fused together as a combined team, that's fine. If they are just literally one team under one manager, that's fine too. But we really need all of these skill sets on the team to be able to actually deliver value. And I'm going to, since we're really short of time, I'm going to storm through the last step of long-term validation, but hopefully it will provide value to you. Okay, so the very first thing is art of pivoting. That is extremely important. After your short-term validation, you most probably run into issues that you did not predict. So it is very important to be very clear about your target, like what is your mission. And if you remember, the mission was that fundamental problem that you were trying to solve. You really have to understand what that is. And that shouldn't really change. But how you solve that, which is your strategy, should change based on your learnings. And pivoting is essentially that. So if you learn anything new about your problem or about your users, about your solution, that requires you to change how you're solving the problem, you need to pivot to that. But you have to make sure that you rarely change your mission statement, your fundamental problem. Okay, so if you remember, the pipeline looked like this. From data collection all the way to deployment and feedback. And if it doesn't solve the user's problem, what are the things that you can do? But once you go from short-term validation, let's say you have identified what kind of problem you're solving and what kind of pipeline you have, and you already have your live data pipeline. The next step is now you have to move from that to an engineered solution, which will be more permanent, and you can use it to do long-term validation. And for that, in each of these steps, you have to do extra work. For example, for data collection, you have to think about things like the quality of your data, the ethics of using that data, the privacy of the users, and the competitive advantage that comes with the data. And the last one is extremely important because in the majority of the rest of the pipeline, there are rarely anything that create competitive advantage for you. Like the models, you're most probably using open source. Building packaging, you're probably using open source or some professional service. Infrastructure, architecture, the majority of these things are known things that you're using. So really the only thing that will create any sort of competitive advantage for you is what kind of data you have. And who else has access to that data. Next one is considerations about your model. So you ideally started from the most base model that you could. it could be a classification with a simple SVM that just helps you build a pipeline end to end. But now you have to think, if it didn't solve the user problem, is that a capacity problem with the model? Like, do I need to go to deep learning? Do I need to use a higher capacity deep learning model, et cetera, et cetera? About the model, you also have to be very careful about intellectual property. And that's a big mistake that a lot of us make. We often just use open source models and libraries without reading their licenses. And we end up using them in production, and that could cause IP problems. Interpretability is an extremely important component for a lot of models we use, because the business needs to understand why the model is making certain decisions. And obviously, there are other types of risks involved with using models. And a lot of companies have model risk departments. But as a small team, you also have to think about what are other risks associated with using this model. On the building side, obviously, that's more of a software engineering kind of activity. But you have to think about various types of testing that you have to do. You have to think about, if you're using containers to package your models, you have to think about how are you going to manage the repositories of these containers. And in a lot of cases, when you're in production, you might have multiple models. They could be models that are used for different times or different user types, et cetera, et cetera. So you have to come up with a solution for model management. And again, like for all of these, there are many open source solutions or managed services solutions. Then on the deployment side, again, the model management is important because the packaging stage and deployment stage have to talk to each other through the model management. Like the deployment side should be able to know which model to pick from the model management and bring it to the production environment. Obviously, when you're deploying a model and make it available, say through an API or something, the security of that is important. Who can access it? How can they access it, etc. How available and scalable should the solution be? Like how many users do you expect to call your API, for example? Does it need to be available 24/7 or only parts of the day? And obviously access is important. From different user types, they might have access to different types of the APIs you have, or different levels of the APIs or data that is producing, etc. And obviously the performance from the software and model point of view, like is the model keeping up its performance over time and with all sorts of users? And obviously the software, let's say the response time, etc., is up to par with your requirements. And on the delivery, if you have a UI, obviously the user experience and the lookings of the user interface is important. If you are delivering through APIs, obviously you have to be very careful about providing instructions about integrating with your APIs. And in most cases, you are integrating your solution into a business workflow. So that's a very, very common mistake, again, that people don't think about this early enough. And then they end up building something that needs to be integrated into a business workflow that is extremely complex, legacy, and inflexible. And you end up with a solution that is perfect in an ideal world, but in a real world, nobody's going to use it because they have to change too much about their business workflow. And obviously, as we talked about the feedback, there is the implicit feedback, which is, for example, things like what did the user spend time watching, or how much time did they spend on this part of the page or this other part of the page, or explicit things like what did they click on, what did they like, etc. And I would like to wrap it up with 2 book recommendations. The first one is Theory of Fun. It's a book about game design, but I really got a lot of insightful ideas from this book about just generally thinking about products. And, I would really like to close on this book called Design Justice. It really brings home the idea of making sure that we have inclusive designs when we are building products, especially machine learning and data science based products, because these are models that are going to affect people's lives, and it's important to make sure that they're inclusive and don't impact people in adverse ways. Thank you so much. I guess we have a couple of minutes for a couple of questions, I guess. But otherwise, please reach out to me at amir@ai.science. And I should say that you can go to our website, ai.science, create an account there to get notified about a lot of free events that we do, as well as the workshops that we hold. We do have a series of product workshops. They help you build simple machine learning-based products based on advanced machine learning. The next one is graph neural net, for example. You will be building simple graph-based products there. It will be announced in the next couple of days, so do make an account there. And I also do free career coaching sessions, and that's a URL you can go to. Or you can ping me, send me an email, or add me on LinkedIn and send me a message, and I'm happy to provide these links if you don't catch them here. Thank you so much. That's all. Okay. Yep, I'm here if anybody has questions in the next couple of minutes. I guess Matthew is commenting that I'm actually not sure what he's asking, but 87% of AI projects fail. Yeah, I mean, that's, yeah, I mean, a lot of the reason that I started thinking about this problem and, collecting a bunch of frameworks for thinking about ML projects in product setting is because of that, because I've been part of a lot of teams that tried to build things and it never went anywhere until I really started thinking about it in a product way. And then we started seeing success. And then later in my own company also, I really tried to follow these frameworks to build our own products. And that really makes a difference. Like doing the upfront, it's a lot of extra work upfront, but that really makes a difference. You make sure you're working on the right problem if you go through these steps. Definitely. So yeah, please, I guess we're out of time. So please connect with me on LinkedIn and send me a note if you have any questions. And I'm happy to continue the conversation there. And also amir@ai.science is my email address. Feel free to send me an email with any follow-up. Happy to chat. Thank you so much.